It's a blueprint. So we have the instruction to create the database. The reminder is how to create the database and how to use such a database. Okay? To communicate with the computer. How can you communicate with the computer? Only languages. So we are going to learn such a programming language, especially database programming language, which is called SQL, Structured Query Language, SQL. So sometimes the student complain, I want to learn the SQL. That's the main reason to take the course. However, you also realize that the SQL part is just part of. You already learned a lot of skill and knowledge and the concept of the programming languages. So we are going to specify the database program languages. So I don't spend a lot of time to instruct how to use the database language because you have learned basic and the fundamental of the database design and database model. So you are able to learn quickly, even by yourself, the database language, the structured query language. Also, before that, some, even including this textbook, some of the textbook database textbook introduce the SQL the first. Okay, if they are focusing on the practical, the program language, they first introduce the database language first, the SQL, then they start to create the table using DBMS first, then explain what is the table, then go back, then what is the database model of such a table, and go back to the what is the fundamental of the such a relational database. That is a ER model, something like that. But I don't like such a way because I'd like to follow the almost the same process and the step as we are going to do in the real life project. In the real life project, we are going to start from the conceptual modeling, then the database modeling, then physical database model using programming language. To understand the program language itself is not very complicated, not very difficult. However, more important thing is how we can get such a database language based on the database model. In other words, relational database model. So, to understand, before we learn the SQL language, we are going to learn what is the fundamental, what is the data structure of the SQL, structured query language. That is called relational algebra and relational calculus. Relational algebra and relational calculus are not much different. Why don't we discuss about the mathematics? Because anyway, it's true. Our relational model comes from the mathematics, the set theory. There are two main areas of mathematics. One is geometry, right? Another one is algebra. You don't want to think about geometry and algebra. What is the main difference? Geometry versus algebra. We'd like to understand what is the mathematics, by the way. It's a kind of a philosophy. Somebody said it's kind of a philosophy. So long time ago, a philosopher would like to find what is the element, what is the fundamental of our life, entire world. So somebody consider fire, water is the fundamental element of the entire world. Okay? Somebody consider something other, which I don't know, which I'm not interested in very well. So each philosopher, each group of philosopher scholar, they try to find what is a fundamental thing, what is a fundamental thing. Then one of the group consider, what about the number? Okay, number is the basis of our life, our entire earth. That partially true. Okay, so for example, Pythagorean theorem. So Pythagorean theorem, everybody knows what is a Pythagorean theorem. It's which my son really hates such a thing. In case of right triangle, so a squared plus b squared is the same as the c squared. Is it true in the out of space? Yes, everywhere is true as long as they are in the Euclidean space. That is actually the Euclidean space is the condition assumption.
It's not the same everywhere then. So if there is a
So that is a condition, Euclidean space. What is a Euclidean space? It's a flat area. Think about the huge white triangle that cover the most of the part of the Earth. Do you think the Pythagorean is true? No, because our Earth is not flat. Okay, it's a sphere. So which means as you can see, if you draw the right triangle over here, the Pythagorean theorem is not true. Okay, it's based on, because at that time when Pythagorean theorem was proved, at the time our Earth is a flat area, they believe. So it's a non-Euclidean. But if we consider Euclidean space, it's anywhere. Even though that is not called the Pythagorean theorem, it's true anyway. In case this shape, triangle or whatever the name is, a squared plus b squared is c squared. So to find such a fundamental thing, like the theorem or the axiom or the corollary, so one group of people would like to use the real shape, like that is the geometry. So a long time ago, Egyptian, they developed a huge skill of the geometry because Nile River, it's every year it's a flooding, but government would like to collect the tax correctly. So every time they need to measure the area of the property, then collect the tax. So they find such a fundamental thing of our life from the shape. On the other hand, in algebra, we try to find such a thing using equation like this. So without using such a, because we can be biased if we draw such a graph or whatever, just using the equation we try to find. So from that algebra, we are going to do the same thing. So we try to use such a mathematical terminology, okay, to find a way to access the data, okay, how our relational data is composed, and how we can access such a data using such an equation or mathematical terminology, mathematical way. That is called the relational algebra and relational calculus. So first, the relational algebra. So by the way, who proposed such an idea? Who proposed? Dr. E.F. Cole at IBM. When he proposed a relational model, he also proposed such an idea to access the data, because relational model itself is different from our array or our existing data structure. So to access the data, access method may be different. So that is based on the relational algebra. Okay. So in algebra, in mathematics, what did you learn the first time? Several symbols, right? So equal means left hand side and right hand side are the same, right? And also we have variable like a, and the exponent is a times a is this one, and also b squared and c squared. We also have the operation symbol, several symbols. So we are going to adapt such an idea. Okay, we are going to use such a name of variable, name of relation, name of tuple, name of the data, and also operation. How can we use such operation? What was it? We are going to define such an operation. Okay, that is called the relational algebra. If you can understand relational algebra, SQL is very simple. It's a very straightforward way. It's just converted into the computer language only. Okay. So first, and also, this is called mathematical equation. By combining several operations like the a plus b minus c divided by d is equal to 2. something like that. By combining several operations, like the fraction and equality and the operation, we call that this is mathematical equation. Similarly, if we combine several algebra operation, algebraic operation, it is called algebra expression. Okay. So first operation. By the way, why do we need such an algebra operation and algebra expression? We'd like to access the data. So this operation provides the method, way to access such a data. The first one is, before we start, so we have the employee relation. What is a relation? Relation is group of data, group of tuple, or group of attribute, right? We can define the group of the data as the relation. So which means we should be able to access the relation by tuple. So we want to access, we want to find something lead. Or social security number is 111, something like that. That operation, access by tuple, access by row, access by data, is called, the first one is selection. So selection means select the specific data. So symbol is sigma. So we are going to use the sigma, just like a plus. This is a plus. Who define? I don't know. There is a promise. If we decide this is a plus, this is a plus. So don't ask why sigma. I don't know. Probably Dr. E.F. who proposed the relational model and proposed this idea. So this is our operation. How we can use? Whenever we access the relation by tuple, by data. How we can use? For example, we have this request. We'd like to select the employee. Okay? Employee. We'd like to select the employee. We'd like to access the employee tuple. But there's a condition. Not all employee, but whose department number is 4. Okay? Or those whose salary is. Why don't we consider up to this one? So I'd like to select the employee. I need to select the employee. Whose department number? There's a DN 1, 5, 2, 5, 3. Whose department number is 4. That means we want to access the data, this one and this one, right? There are two things we need to consider. One is name of tuple, a name of relation. From the employee, we'd like to access, we'd like to retrieve whose department number is 4. That is a condition. So employee is a target to access. And select. This is a selection. We try to select the employee. Then here as a subscript we can specify the condition. Not all tuple, but whose this condition is DNO is equal to 4. Right? DNO is equal to 4. So this is the notation to access the data by tuple, which is called selection. So how can we access the data? How can we access the tuple? Using select operation, selection. So name of relation with the condition. It's kind of filtering. Okay? Then, what is the output of this selection? List of employee whose department number is 4. List of employee. List of group of data. Which means output is also relation. What is a relation? It's a group of data. Each tuple has the same attribute. So output of this one, so this tuple and this tuple forms another relation. So This is the output of the result. This result. Or sometimes you can name as employee DNO4. It forms another relation. So this is another characteristic of the relational algebra operation. Any relational algebra operation, output of the relational algebra is also relation. Okay? Which means output can be used for input of another relation, another operation. For example, so we have another condition, that is whose salary is greater than 30. This is the relation. Okay? Select salary is bigger than 30K. Does it make sense? Yes, because it's a relation. Output of this relation can be input of another relational operation. This is what we want. So we can use the select. But somebody already realized, in this case we can combine into one. So this is the same as select employee DNO is equal to 4 and salary is bigger than 30K. We can use logical operation also. And or others. Exclusive or very easy actually. So we can use exclusive or also. No, not operation.
No.
So something like that. So we can use mostly or and or operation. We can use combine. Okay. So this is a select operation. How can we use selection operation is can be used for to select specific data. Okay. At that time, notation is in parentheses we can put the name of a relation. It doesn't have to be existing relation, existing table, but it can be also output of another relation like this one. Then give the condition as a subscript. So we are able to access the data by tuples. What about attribute? What is the another definition of the relation? Group of data, group of tuple, also group of attribute. According to the definition of the relational model, there are not much difference. Number of attribute, number of tuple, it's the same thing. The only difference is row, column. Okay. However, nowadays, usually number of data, number of rows are much bigger than number of columns. Because of that, current DBMS system, including Oracle Info, the commercial relational database management system focus on how to access the data fast, efficiently. However, nowadays it's changing, getting changed. For example, we have millions of temperature sensors. So we deploy to the United States, all the places. Then every hour we collect the data, temperature. Okay? So column, sensor 1, sensor 2, sensor 3. How many sensors? Sensor millions. How many column? Millions of columns. Then data will be inserted. So every hour. How many data in a day? Only 24 rows. Problem is, sometimes I'd like to get the sensor data only in Connecticut, for example. Or sensor temperature data above 100 degrees. Or something, the condition to select this column by column, attribute by attribute. So this is called data-centric approach. This is a column-centric approach. So nowadays, even column-centric approach is highlighted. So to support such a column by column, so I don't want to get the all attribute, only specific, that is called projection. The second operation is the projection. Projection means the specific attribute. How can we use? This is a symbol. The capital letter pi in Greek letter. Don't ask me why. So the Dr. EF code selected this one. Then it's the same idea. We can put relation name. So I'd like to select the first name. You can list the column here. The middle name initial, last name. Like this. Output is also relation. So we can say that this one is the employee name relation like this. Which means this one can be used with this one. So why don't we change it? I'd like to select employee's name. First name, middle name, first name and last name. Whose department is the same condition. How can we change this one? Here. We can use output of this one for the input of this projection. This first name, middle name initial, and last name. And this is the result. This is also relation. Okay? So at that time, how many operations are used? 1, 2. If you are using multiple operations, that's called relational expression. Like think about the English. So in English sentence in English consists of a number of words. So using word, you can make the sentence. By combining several sentences, it can be paragraph. Then finally, the article. So it's the same idea. So each of them is called operation. And by combining several operations, it will be relational expression. Our goal is to find relational expression. These two operations are most popular. Okay? So, for example, in this case, so if we apply the relational expression, like for example, first name, last name, this will be selected, and DNO is a 4. So these data will be returned, including the AMEN. So this will be returned. This is also relation. Okay. So this is the
only the first one will be returned because you have to condition.
Oh yeah, salary. We have the salary also. So we need to only this one. That's good.
Sorry.
And because the salary is bigger than higher than 30K, only one tuple will be returned, right? So this is also relation. This is the output that we want. So select operation, as you can see, so as we have seen, the condition can be combined. It's commutative, okay? And also we can separate, and also we can change the order. So obviously, okay. So this is the last one of today's lecture. What about this one? Can you understand the meaning of this? Employee. Department, in the department number 4, whose salary is higher than 25K. Or from the department 5, whose salary is 30K. Okay? Then we can get this data for example. So output of this is also relation. And also you can use the projection if you want to specify only name. Okay? So that is the projection. You can list up the attribute. Okay, so the projection also, you can use the commutative. You can combine or separate. Okay, so we will see next one. Any question?